Software is nice and rigid and stiff, does what you tell it. And business environments are insane and impossible to predict and impossible to control. We're not just producing clones who sit and write code that can be replaced by LLMs, but we're producing human beings who have to interact with human systems, and we're sending them out there with knowledge of nothing more than the code to interact with these human systems. And we're doing them a disservice. We're making their jobs harder. And to be able to build software requires that you can interface with both sides of this. And programmers are very definitely taught and selected for their ability to think linearly. And that means solving problems, thinking logically, taking one step at a time, always being correct, being very critical in how you view things. You can start with the fathers of computer science, so Turing and von Neumann. You work backwards and you realize that Turing and von Neumann both worked with Wittgenstein and Russell, who was influenced by Frege. And you take another few steps back. So it doesn't take long to get back to Plato and Parmenides, and you realize that, God, this is not something that's just turned up in the last 50 years. This is a way of looking at the world that's been around for a very, very long time. And the paradox is that particular way of thinking, which in the book I relate back to Frege and Russell and Wittgenstein, that particular way of thinking is incredibly necessary to invent the computer. We would never got to Alan Turing, we would never have got to the computer without that way of thinking. But that way of thinking turns out to be absolutely horrendously horrible for dealing with or describing or managing any kind of human problem. And as soon as you apply it to a human problem, the only thing you can do is create constructs that are rigid and brittle. And the problem, as I've seen it, is that those static models describe a snapshot of the business environment at one point in time from one person's perspective. And that reality keeps moving and keeps changing. And as that reality moves and changes, anything that we've put into software, into code, cracks and breaks. And then we experience poor quality software. We have to change it. It takes time. It gets more brittle every time we touch it. And what I've said is that we can't live in this world where we believe in this static snapshot of the business environment. It doesn't exist. It just never is like that. And the residue is a kind of clever little trick that says, look, there is a snapshot of the system at this one particular time. And we'll wrap that in a wrapper called the residue. And a residue is just whatever's left over when the system breaks. And then you tweak your original architecture so that when we go down that trouser leg, the thing that breaks still keeps working. And software has to be based on a model of what's going on, because it's based on a model we have of a human system. And the software becomes even more rigid than the model itself because it's encased in code, difficult and expensive to change. And what happens is that we use this linear way of thinking to model the human system. Then we take that model, turn it into code. The human system moves and the code breaks. And so the architect's paradox is that this linear way of thinking that gets us to the computer causes a crisis when we try to apply it to the human systems, which we're trying to use the software to help. And here's a set of tools that allows you to live comfortably with this uncertainty. And not only that, but to leverage the uncertainty to get to a result, which, while it's not certain, is scientifically as good as we can get. That shifts everything. And it shifts the way we talk. It shifts the way we look at problems. The feedback I get from developers and people in the field is that it's a relief. It's like, wow, we don't have to pretend anymore. I would say that given my education, which was pure mathematics followed by software engineering, that the education and this default philosophy that all people who follow that track that I talk about in the book pick up shuts you out from a huge chunk of the world, a huge chunk of life. And what the philosophy has done for me, while staying very close to the code, is brought me and pulled me into contact with all kinds of things.
Hello, everyone. Welcome to Love and Philosophy. I'm so glad you're here. Today I have Barry O'Reilly with me as my guest, and I'm very excited about this one. Although it's about a subject you might think isn't philosophical, which is software development. But anyone who's studied philosophy knows that there's so many metaphors or even ideas that are taken literally in terms of computation, in terms of the way we build our computers, the way we think about them. And this is sort of flipping that script in a way, because here's a guy, Barry, who's worked for a lot of top companies. He's really good at his job developing architecture, software architecture. He's an architect in this world of coding. and software development enterprise architecture. Started out in math, pure mathematics, became a coder, a software architect, and he's bringing complexity theory into software development, which is the first time that's ever been done. I find it extremely exciting. I really think he's got something urgent to teach us as philosophers, even though philosophers might quibble a bit with his interpretations of philosophy. If you read his book, he actually does a very good job of it. He's really studied and condensed so many different sorts of philosophies in a way that actually makes it very understandable and brings something really important to software architecture. He's actually come up with a whole new theory in software architecture, which actually has to do with the way that it's done, and it's called Residuality Theory, and it's a theory of software design that tries to make it easier to design software systems based on these complex systems notions for the real world, for complex business environments, for complex everyday life, for the kind of problems we actually face as humans, as life, even though we have to use this linear code to solve them. So he's holding this paradox. He actually talks about it as a paradox, as you'll hear. It's a theory that models software systems as interconnected, and he has this wonderful idea of residues, and he's working with the residue as a kind of unit. This is a really good introduction into it, and just to understand how it's important for philosophy, and also why philosophy can actually be helpful in the real world of business and computer design and computer software. He's basically coming up with an idea of process modeling. He's using process philosophy and complexity theory to come up with a way to do the software architecture that actually works. It's actually been proven to work. A word he talks about a lot is uncertainty. So he's finding a way to manage uncertainty, which is a part of all design practice. Even though we code in a very linear way, the problems that those codings are solving in the real world are messy and uncertain, full of chance and change. And for those of you who are coders and software designers, this is an introduction to philosophy that can be really helpful to you, his work, because he really spent years and years reading through everything from Plato to Deleuze and noticing a lot of the residues, dare I say, that have come out of philosophy, but that people didn't necessarily think of as philosophy. He talks about how everyone has a philosophy, we just don't know it, which is something I've said myself, actually, or that a lot of us have been talking about lately, which is maybe one reason we ended up finding each other. In any case, I hope you will listen to this conversation through to the end, because it really gets good towards the end. I think it's good all the way through, but these aren't necessarily easy ideas, and we're combining a lot of worlds here, as usual, with love and philosophy, but they're all connected by this idea of paradox, holding the paradox, looking at the world a bit differently, thinking differently from the either-or mindsets that characterize so much of what we do every day and how we do business, and not saying that those are bad. This isn't about coding being bad or linearity being bad or any of that. It's just a different way of approaching it, which actually allows some more randomness, some more entropy, while at the same time giving us a different kind of order. So that reminded me a lot of the conversation I had with Carl Friston, for example. There's a lot of ideas from all the other conversations in this one. So a lot of these episodes have a lot to do with complexity and complexity science. We mentioned it in the last one with Kevin Kelly, the tech maverick, co-founder of Wired Magazine, and then there's a few other talks coming up which have quite a bit to do with complexity and philosophy and physics. But this one is really fascinating because it's in a very practical, everyday application, software design, software architecture. However, I find it very fascinating too because of the way we talk about computation and the way we talk about computers within philosophy. I actually see this as very helpful for breaking out of that mindset a bit and also being able to hold it and understand the worth in it at the same time. I hope you enjoy this conversation. I hope you'll go and find Barry's talks on YouTube, which I'm linking to, of course, in the show notes. They're really worth watching, listening to. His books are great too. I read them, loving them. There's a lot in there you'll recognize, but there's a lot of connections that he makes because he's coming at it from a different way that even if you're a philosopher and you're very trained in all the philosophy he mentions or talks about, you still get something out of it. And if you're a software designer, a coder, you get an introduction into philosophy that will make a lot of sense to you. We also come back to the idea of care and love, what it really means in the world to be embracing uncertainty and not to be just holding on to this linear way of thinking and imagining that LLMs and the whole AI revolution is somehow safer or smarter or anything like that. It's just a product of powerful technology that's been formed with a linear mindset. There's a whole other world. There's a whole other side to the paradox, and it's time to explore it and even embrace that uncertainty and let it open us up to the world again. And I also want to say, I think residuality theory probably could have some interesting applications in other fields. No one's really tried it yet. I've just learned about it, but I've already had quite a few ideas relative to neuroscience, which of course I won't have time to test out myself. Just for those of you listening, maybe it sparks something. Maybe it's worth actually listening to the end and looking at his videos, because there's a new approach here, especially for those of us coming at it from the traditional routes of cognitive science. I'm always happy to hear from you, hear your ideas, and I hope you'll support the show in whatever way you can. Hope you're having a beautiful May. It's the month of my birthday, so it's one of my favorite months. And things are coming up from the ground, as I said last time. It's been very sunny. I'm off to Japan, so I'm sending you a lot of love today. Hope you're doing well wherever you are, and that something good happens in your life this week. All right. Cheers. Shall we start?
Yeah.
Okay. Hi, Barry. Thank you so much for being on Love and Philosophy. It's wonderful to see you today.
Thanks, Andrea. Cool to be here.
I just thought at the beginning, maybe you could just tell everyone a little bit about yourself. You have such an interesting history. We're going to talk about your 2 books a bit today, but first, who are you, Barry O'Reilly?
Yeah, so my name is Barry O'Reilly. I live in the archipelago outside Stockholm in Sweden. Originally, I grew up in Ireland, in the north of the country. I've worked with software engineering for a very long time. Originally, my first degree was in pure mathematics, and got into the software industry, and worked for a very long time there as a software engineer, software architect. Worked for Microsoft for quite a few years, led the solutions architecture community there, became a chief architect, and in that time got very interested in the idea of what is a software architect, because no one really knows. And got really into trying to define what that is. How do we teach architects? How do we become architects? Because it's all very accidental. It's all very random. The industry is very immature. Doesn't really understand what we're about yet. And from there, I had a bunch of ideas about how we should do this, how we should carry this out, how we should be as architects. And I started to speak on the IT conference circuit, but I was a little bit disillusioned with it, because it's, at IT conferences, you can get up on a stage, you can say anything, and people would just nod and say, that's really interesting. And you don't have to verify anything, you don't have to validate what you're saying. And I felt that I wanted to go deeper. So I started a PhD. I got interested in the links between what we do as software architects and the complexity sciences, started to investigate those things, and sort of pulled on that thread until eventually I ended up looking into philosophy, encouraged by my wife.
Philosopher?
She's just finishing her PhD in education. So she was the first philosopher in the house, and she kept leaving books on my desk and saying, you need to read this. You're like, the things you're talking about have already been talked about. You need to read this guy and this thing and that. And so I started to get deeper and deeper into that, and then maybe went a bit too far. And so last year I was asked to write a little booklet for a conference, and they would give it away at the Domain-Driven Design Conference in Amsterdam. And they were going to give this little booklet away to everyone who came to the conference. And so there was some kind of mix-up in communication. And so by booklet, they meant 16 pages. And so I sent them a message when I got to 200. I was like, this is going well. This is going well. And they're like, no, stop. That's not what we meant. So eventually we compromised on like 72 or 74 pages. Then people started to hear about the book. So they started to write to me and say, how do we get this book? I was like, well, it's not for sale. So I published it online through LeanPub, and it turned out to be a big success. And one of the things that happened to get it down from 200 pages, I had to take all the philosophy stuff out, and that was just sort of lying there on a shelf um, in my hard drive. And then I did a talk at a conference, the NDC conference in Oslo, about the philosophy behind architecture, and discovered that it wasn't just a niche interest that I thought was interesting, but lots of people were very interested in it. So I took those extra pages and turned them into the second book, which was released in February this year.
Well, that's the more
And
philosophical one
yeah,
side of
and
it.
that's the architect's paradox.
It's very interesting because you're
Yeah.
kind of you're bringing, as far as I know, you're bringing complexity theory into software architecture and coding, and I'm not sure that's ever been done before. And it's this whole new world relative to what it could mean to be an architect in terms of software. Did you already start having these ideas relative to residues, to the residuality theory before you went back to school? When did complex systems come in? Like, how did all this, how did you
Yeah.
discover this?
So I was given a job while I was at Microsoft. I went over to the head office and they said to me, "Look, we need someone to teach the next generation of architects because we're having some struggles. Sort of people who can cover the technology, because technology at the time was changing and we're moving to cloud-based systems, which was challenging for a lot of people. So a lot of our old knowledge was crumbling away, and we were expected to learn new things." And we were also expected to be able to translate those new things into business environments. And so business environments are very different things than software. Software is nice and rigid and stiff, does what you tell it. And business environments are insane and impossible to predict and impossible to control. And so I started thinking about, how do I teach this? And I had to ask some hard questions of myself. And how do I do this? Because I'm not entirely sure. And at that point, I'm fairly confident that I can do this job well because it keeps working out for me. But I can't articulate, what do I do? How do I know what to do? Where these ideas come from? How do I know what to say next? And I started to dig into that and realize that sort of myself and other senior architects had a grasp of complexity or sorry, a grasp of uncertainty, or a comfort in uncertainty that sort of junior architects and developers just didn't have. And so if things started to become uncertain, where you couldn't really grasp what's happening in this business system and no one could tell you what was happening, and there was a lot of uncertainty around, how does this work and what are we even trying to do, you would see junior architects, junior software developers melt away and just not really know how to handle it. And senior architects and people like me would think, oh, well, now this is interesting because no one knows what's going on and we don't know what we're going to do. And it's really difficult to map this to software constructs. It's not textbook, it's not easy. And so I started to just read a little bit on what is uncertainty, how do we deal with that? And so as a mathematician, you end up, of course, always coming back to Bayes' theorem and things like that. There's a lot of ideas around that, and they all sound real good, but you can't apply them to real life. You can't do anything really concrete with them. And so I just pulled on that thread. I ended up in the complexity sciences, reading people like Ralph Stacey and Nassim Taleb, and then I started to formulate my own ideas around that, and um, the early incantations of this were based around Taleb's idea of anti-fragile. I realized that it's a good metaphor for what I'm doing, but it doesn't capture what I'm trying to do at the component level. And so the concept of residues was born out of melting all of these ideas from the complexity sciences together with the ideas from computer science and practical experience, and sort of trying to capture what it is that senior architects do in a way that, as I've presented these ideas back to the community, in a way that senior architects themselves were doing but couldn't articulate. And that's been nice to hear from people in the industry say, look, I already do this. What you're describing sounds really familiar, but we've never had words for this before. We've never been able to say what it is that we do until now. And so it was more or less going to Google, typing in the word uncertainty, clicking on the first few links and going, okay, it's this. And then I wrote a few articles. They got published in some computer science journals. And then I decided to do a bit more with it. So I found a university and started working on a PhD, which I'm writing up as we speak. So, well, not literally right now, but this week I'm supposed to be writing it up.
Good luck. Well, you have written 2 books in the time that you
Yeah,
were writing your PhD, so you're doing a lot of writing, that's for sure.
yeah.
You said you studied math first. Were you already interested in Bayes and all of this? Because that's not exactly. I mean, there's a lot of different kinds of math, and that's not necessarily typical, or it's becoming more typical. But
Yeah, so the math that I studied was pure mathematics. So
okay,
algebraic topology, linear algebra, things like that, and math for the sake of math. Absolutely no
not
application
statistics. Okay,
whatsoever. No statistics. Statistics was a dirty word in our department, so we didn't do any of that. Statistics came much later, maybe 10 or so years ago, when in the last wave of machine learning interest, then I had to get into statistics. And then obviously as part of your PhD training,
Yeah.
there's a lot of statistics in there. But yeah,
It sounds like you were doing something that was working really well, as you kind of said, and you were succeeding a lot in Microsoft and all these big worlds. And then you started trying to figure out exactly why, and you hit upon uncertainty. Was it your capacity to handle uncertainty? Was it what was it about that word? That word is important. It's I think it's in the title of both your books, even.
it is, yes. So it's the ability to work in uncertainty. And so if you study computer science or software engineering, um, there's always someone who tells you, look, this is what we're doing. This is the duty. This is the task. You need to build a bit of code that does this. You need to build a bit of code that does this when you're doing your assignments and all of those things. And when you're a developer, then there's these people who appear around you, business analysts, requirement engineers, people who tell you, we need to build this, and you need to build that, it needs to look like this. So you talk to a user, and the user says, I needed to do this. When I click on this button, this needs to happen. And it's always done from the perspective, and it's taught from the perspective, that we can be certain about what users want or what's actually happening in this business environment. And if you're not certain about that, then you can become certain by asking questions and making sure and double checking that this is what we want. In the real world, it doesn't work like that at all. So businesses don't know what they want. Users don't really know what they want. They have opinions, but they don't know what they want. They're not entirely sure what they need. And it doesn't matter even if they did actually know what they wanted today. Everything's moving, everything's changing anyway. And you get to a certain point where you realize that the coding bit, that's easy. That's trivial almost. The real challenge is that when everything's moving, everything's swirling, how do you decide what to do? How do you build a piece of code that can react to an environment that could lurch off in any direction at any one point in time? And that uncertainty I find across my career, that's what I look for in a project, because there's no uncertainty, there's no fun, there's no challenge. And it's also the thing that kind of makes or breaks a career. If you can handle that uncertainty in a software project, then you're going to be able to cope with these kind of environments. For many people, it's a ceiling. When they can't get that kind of certainty, then they just push it back onto business people and say, we're not doing this. There's nowhere in our educations as software people do they teach us how to deal with this kind of uncertainty, apart from be more certain, or ask them to explain it again, drill down into their language, force them to express themselves in a way that's clear. And we learn about these things, to like how you harden a requirement, how you get someone to be absolutely explicit about what it is that they're saying, and things like this. And so the answer is always that the answer to the uncertainty, as we're taught, is to get rid of it. Whereas a senior architect, someone who can handle these things, can learn to live with that, and learn to live with the fact that there's always uncertainty in a business environment. And senior managers know this. They know that you can't be completely certain about everything all the time. And so what I've seen, that the step from being a programmer, someone who just writes instructions, tells the machine what to do, to being an architect is being able to cope with this natural uncertainty that exists in any human environment. Any collection of people will produce a great deal of uncertainty just when they speak to each other about a particular problem. And for me, that became fascinating, and that's the bit that I drilled down into, because when you see projects fail, and an enormous amount of my work has been rescuing projects that have crashed for some reason, and over and over and over again, we see that this uncertainty causes flux, it causes problems, it causes people to either check out and not make any decisions, or go too hard in and make too many decisions. And how do we handle uncertainty in our software projects is a central theme to everything that we do. And it's kind of the dividing line for me between the architect and the programmer. Can you handle uncertainty? Then you're ready for architecture. And we have a very ambivalent relationship with it in our industry. Most of the time, we like to sweep it under the rug. Sometimes we like to talk about it, but we talk about it in terms of how we kill it, how we get rid of it, not how we can actually use it to drive a result.
Yes, that's one thing I love about both books is that I talk about holding paradox a lot, and I feel like together both those books are holding the paradox, which means you're not trying to smush one side into the other or resolve it. You're recognizing that it's not resolvable in a sense. And, you're not trying to get rid of the uncertainty necessarily. It's almost a plus, isn't it? Something to play with. You talk about the gap between programming and the architecture or software architecture. Maybe is that something that people recognize before you started writing about it like this? Because I hear it a lot of different ways, like everyone's just a programmer. And that means that is that kind of linear thinking that where uncertainty isn't good because, you're writing code and you don't want it to crash. So can you talk about that tension a little bit?
Yeah, so the tension that I describe in the book is that as a programmer, you're taught to, first of all, taught how to think in a very linear way, which is good. And most mathematicians can do this, think quite linearly, at least in the early stages. And programmers are very definitely taught and selected for their ability to think linearly. And that means solving problems, thinking logically, taking one step at a time, always being correct, being very critical in how you view things. And the paradox is that that particular way of thinking, which in the book I relate back to Frege and Russell and Wittgenstein, that particular way of thinking is incredibly necessary to invent the computer. We would never have got to Alan Turing, we would never have got to the computer without that way of thinking. But that way of thinking turns out to be absolutely horrendously horrible for dealing with or describing or managing any kind of human problem. And as soon as you apply it to a human problem, the only thing you can do is create constructs that are rigid and brittle. And the human system will move, and those rigid, brittle constructs will smash and crackle. And software has to be based on a model of what's going on, because it's based on a model we have of a human system. And that software becomes even more rigid than the model itself because it's encased in code, difficult and expensive to change. And what happens is that we use this linear way of thinking to model the human system. Then we take that model, turn it into code. The human system moves and the code breaks. And so the architect's paradox is that this linear way of thinking that gets us to the computer causes a crisis when we try to apply it to the human systems, which we're trying to use the software to help. And so we're caught in this never-ending loop of crisis. And this was realized by our industry already in 1968, when they had this big meeting in Garmisch in Germany called the NATO conferences, and all of the big names of the software engineering industry of the day met and said, why do we have this constant sense of crisis? They still haven't really figured it out. So in 1968, the conclusion was, we are not good enough engineers. We need to be better at engineering. We need to go back to the drawing board and come up with better ways. We need to be more precise. We need to be, it was kind of doubling down on that linear way of looking at the world. And it's only really with the advent of the agile movement, which happened around the turn of the century, when people started to say, maybe we need to just chill out a bit and stop trying to be precise and stop trying to map all of these things so meticulously to logical structures. Maybe that's getting us into trouble. And the problem with the agile movement is that they were absolutely right in this diagnosis, but they threw half of the stuff out, all the stuff that the managers were using, and said that all that rigid linear stuff doesn't work for us. But they kept the rigid linear stuff within the code. Ideas like object orientation, where you model the world as a series of interacting objects inside your code. They kept a lot of those things, which are just as guilty as the stuff they were throwing out for bringing rigidity to something that needed to be fluid, that needed to be able to move. And that it's that paradox that's constantly there. And I describe it in the book. It's not really an intellectual problem. It's a full-blown identity crisis, because our industry is only 70 years old, and we're still asking, who are we? What way do we look at the world? And we were born, as the book says, in mathematics, which is where we come from. That's our first tool. Our first weapon of choice is logic when we try to solve a problem. And there's a stubbornness to how we approach these human systems with logic. We won't give it up. We won't let it go. Long after the death of logical positivism, we're still trying to model these systems as structures of statements related to each other. And so the book is very much about not breaking this paradox, not solving it, but just get comfortable with the idea that these two things are always moving around each other. One is trying to destroy the other constantly. Logic is trying to impose rigidity on the fluidity of our human systems, and the fluidity of our human systems breaks our software constantly. Once we're aware of that, it changes how we think and design and build software.
You talk about it almost as if it's an awakening to a new kind of life too, which I think is very important. I mean, this nests and scales into a lot of things that's going on today. When you're talking, I'm thinking about computational theories of mind and the ways that we think about what a body is and stuff, and how that's related to all these ideas that you present. And maybe we should talk about residuality a little bit first. What actually is this kind of alternative that you're presenting for how to hold this paradox, so to speak, or where are you turning the attention from? I mean, even maybe for someone who doesn't really understand what agile and all of this is, maybe you could set up a little bit of how you've kind of shifted the playing field just a bit.
Yeah, so it's been fairly standard. If we go back to the 1950s, so look at computer science. In the 1950s, computer science was computing was just basically a list of instructions that you told the computer to do this and do this and do this and move this bit of data over here. And when you're finished doing this, jump back to line 20 and then start this bit all over again. And this started to cause a whole lot of problems because it got very complicated. If you tried to make a change in that code, then you had to know which lines does it jump to, where does it affect, how do I change this? And so people got frustrated with this, and the solution to this was considered to be by the late 1960s to break your software up into many small pieces, and just have small pieces of code, not one big file. And these were modules. And then what starts to happen is that we say, well, what's the best way to break our modules up? How do we break them up? Where are the boundaries? And we started to look at the real world. And we started to look at, well, here we have a business system. And in that business system, we have something called a customer, and we have something called a product. And we have to store data about these things. So wouldn't it be smart to break up these pieces of code so that we have one piece of code that's just about customers and one piece of code that's just about products? And so we started mapping these pieces of code to concepts in the real world, and it became this idea of objects, and it became very much about things. And so what are the things in the world? And that's where the programmer would start. And this is driven by various trends, including how we model things in databases and things like that. And so the software engineer, before they decide what are the modules that's going to make up my application, they would look at the world and they would look for nouns and say, well, all the nouns are going to be, all the things are going to be little blocks of code, which we call objects. And inside those little blocks of code, we're going to have functions that execute and do stuff, and some data, perhaps. And this is the way I was taught to do software. That's the way most people are taught to do software. And what we end up with are these static pictures of the reality around us. So say, here's a customer has multiple products and has an address and has a credit card and all of these things, all these links and structures that we start to build up to describe the business environment. And the problem, as I've seen it, is that those static models describe a snapshot of the business environment at one point in time from one person's perspective. And that reality keeps moving and keeps changing. And as that reality moves and changes, anything that we've put into software, into code, cracks and breaks. And then we experience poor quality software. We have to change it. It takes time. It gets more brittle every time we touch it. And what I've said is, like, that we can't live in this world where we believe in this static snapshot of the business environment. It doesn't exist. It just never is like that. And the residue is a kind of clever little trick that says, look, there is a snapshot of the system at this one particular time. And we'll wrap that in a wrapper called the residue. This is what it looks like in these particular conditions. But if something twitches, if something changes in the environment, then we go down another trouser leg, a different timeline, with a different impact, and the architecture will break. So we need to change this a little bit so that it will live in this trouser leg. It'll continue to work. We call that a residue. And a residue is just whatever's left over when the system breaks. And then you tweak your original architecture so that when we go down that trouser leg, the thing that breaks still keeps working. And what we end up with is, rather than just one static picture, we end up with potentially hundreds of little pictures of the changes our architecture needs in order to be able to move through all of these trouser legs in different orders at different times. And it has, in philosophical terms, we're moving from, a structure or a Platonic ideal to Bergson's multiplicity, this thing that can go off in any number of directions. And that's a pretty huge shift. Philosophically, very, very difficult to get engineers on board with that, especially because we're using our imaginations to talk about what these trouser legs might be, right? We're not saying that this is definitely going to happen. A lot of programmers find it very difficult to build a software system whenever what we're talking about might not happen. We have to be certain, we have to be sure this is going to happen before we spend any money, and that's a very difficult topic for them to even talk about. And so this leads to a completely different way of thinking about systems, completely different way of modeling them. But the results that we get out of this, and this is what I've been able to show empirically, is that when you think this way about a system, you produce a software structure that is more likely to survive when something unexpected happens. And something unexpected happens all the time when you build software. There's always something that isn't in the spec. And so what we get out of this way of thinking is a software system that survives off spec. And that's a huge benefit as a software architect. And it's the only reason we exist, because if it was just requirements and we just had to build in a world of certainty, then we wouldn't need an architect. A programmer could do everything. And so what we get is a system that's going to survive things that aren't in its spec, things that haven't been described, stuff that's in its future. And it isn't just particular things, but it has a tendency to survive off spec. And that's the thing that makes this interesting, that this way of thinking offers to the teams who use it.
It almost sounds like classical mechanics, Newtonian sort of worldview, or like the clock or something. And in the books a lot, you do sort of give this impression that a lot of coders and software architects were sort of living almost like in a matrix kind of world where we pretend like everything works like clockwork, and we pretend like the Newtonian model always works, even though it's always breaking. So there's this kind of constant tension, and as you even say, it's even a little bit lucrative at times because, of course, it's going to break, and then they need you again.
Yeah.
And, yeah. And I feel like you're now kind of trying to open up to process philosophy and complexity theory and all of this. Had anyone tried to do that before, as far as you know? Because when you bring in Kaufman networks and all of this stuff, yeah, is this a first for coding, or is there a precedent?
It is. In the world that I live in, which is enterprise software, it is a first. People have not brought this kind of thinking into software engineering before. There have been attempts to bring complexity into computing in the last couple of years, but they've been very much focused on the concept of teams. And they've led to very sort of fluffy advice, where we'll talk about systems thinking and we'll say, hey, you have to think about the whole system, not just the one little part. And it's all this kind of, and programmers immediately become skeptical and say, yeah, but what am I supposed to do with that? Tell me what to do is what they want to hear. To bring in the Kaufman stuff to talk about process philosophy is a huge jump for programmers. And for many, a jump too far because they don't even know what problem is it solving. And I say, well, we're solving the problem with substance philosophy. What's substance philosophy? It's the fact that you think everything is an object. And for some people, that's swearing in church. You're not allowed to say that the object approach to modeling the world is deeply philosophically flawed. So this is a huge jump for most people within technology. And for that reason, I assumed that, no one's going to be interested in this. No one's going to want to hear me talk about this. So when I went to this conference in Oslo, I thought, they asked me to give a talk. I had this on the shelf. I said, I have this talk about philosophy. I'll do that. And I thought they're going to stick me in a tiny room. There'll be 4 people there and we'll have a nice chat. And I got to the conference and they put me in the big room. And I thought, well, this is going to be really embarrassing because it's going to be this big, massive stage with 4 people, but they put them 20 feet away from me. So you lose that personal touch. And then 400 people turn up in the room. There's people standing in the aisles and sitting on the floor in front of the stage. I'm like, oh, this is going to be really bad because I'm about to tell 400 plus developers that they need to turn to process philosophy and they're going to throw chairs at me. This is going to be really boring. And they absolutely loved it. And I was blown away that there is real interest. If you set these things up in the right way, if you just come in and talk about process philosophy and how everything would be better if we looked at things this way, they won't listen to you. But if you talk to them and say, here's a bit of code and here's why it's going to go wrong because you're thinking about the world in a particular way. And if you think about the world this way, the code's going to shift and change and go this way. And this solves a real problem for you. And people have really appreciated that. And I've been absolutely blown away by the response from the technology community, from the tech community on these kind of things, that there is a real hunger out there because people realize that the old ways of thinking about these things, which have been around for a very long time, so the way I describe things, the last real paradigm shift in software engineering was 1968. And we call a lot of, in software engineering, there's a lot of marketing hype. So every 6 months we call things a paradigm shift. But the real shift in paradigm was the engineering paradigm, which was born at that conference in 68. We haven't had a shift and people are hungry for something new. And when they hear something new, it catches their attention. And I think that the industry is ripe for a new philosophical way of looking at things.
There's also this word crisis, which I think is in 1968. It was called the software crisis, right? Wasn't that kind of the revolution that someone said it's a crisis? And I feel that word is really potent and present today too, isn't it?
Yeah, so the software crisis basically says, why do we never deliver anything on time? When we do deliver, it doesn't work. And why do we fail to deliver anything so often? And that was a big problem in 1968. There's a lot of people today, we have a lot of software running in the world. And so people assume that, well, we must have solved all those problems, but there's an awful lot of software has to go through convulsions before it's released into the world. An awful lot of enterprise software dies, and an awful lot of it costs way, way more than it should. And so there's this Silicon Valley narrative where we've mastered this, we can do this now. In fact, we can actually teach other machines to do it for us, and we don't have to do it anymore. The truth is that software engineering is expensive, painful, and risky for almost all organizations out there. And we still haven't really matured. We still don't really know what we're doing, I saw a post today saying that, you wouldn't fly in a plane if the pilot didn't have a pilot's license. So why would you let someone build software when they don't have a license for building software? And my thinking around that is, really we have to get a few more planes in the air and stop crashing them before we start thinking. We have to sort that problem out first before we start thinking about pilots licenses. And so we haven't really matured as an industry yet. There's still quite a way to go. So there's still a permanent kind of sense of crisis that most companies will have a number of projects who are in a state of crisis right now, and they will be failing and they won't know why, and they'll be bringing in industry best practices and throwing all kinds of tools at it. They'll be losing money. It eats up morale. It's not a solved problem.
It feels like the crisis is even deeper though to me because there's so many kind of layers to this, and I'll just throw this out here. It's a little messy, and you can just I would just like to know what you think, because there's this like why is everyone responding so dramatically to you? It feels like it's personal in a way too, in the sense of that people have been living in a bit of an imaginary world, knowing it's not actually real because you are designing this in the real world. I mean, I think about when you talk about one of the examples you talk about, like the car, the materials of the car aren't changing, but in this world, like what are actually the materials? Like what are you working with? It feels so ephemeral and matrix like, and it seems like some way to solve that crisis is just hold to this linear mindset, do the coding, be told what to do, and that seems to go towards what you call stillness or maybe stasis even. And I feel like that's bigger than just, in this software world. It's kind of everywhere now. I don't know if that even makes any sense to you, but and even in your own life, like, why did you go study philosophy? You must have studied philosophy for years to be able to write and understand all this complexity, theory, process philosophy. I mean, was the crisis bigger for you too, or how do you think about that?
Yeah, so for me personally, it came from a sense of frustration. It came from a sense of frustration with the state of the industry, frustration with people constantly telling other people this is how you do it, when it very obviously wasn't how we did it, and a frustration with my own inability to understand what is it that I do. I'm doing something, and I'm good at it. I have no clue what it is. It's an instinct that I built up just by luck, by being in the right projects for a couple of years and seeing the right problems. And I have an instinct. And so Donald Shand talks about this in a book called The Reflective Practitioner, which was written in like 81 or 83. And he said that there are people who build up a professional aptitude for problems. They don't know where it comes from. They don't know how it got there. They get there by reflecting over things that have happened every day for a long period of time, and then suddenly they can do something. They don't know why. And I wanted to dig deeper into that. I wanted to understand why do I think like this? Why do other people in my industry struggle to think like this? How can I get them to understand me? And a lot of frustration because I would come into a project that was failing, and I would see these linear thinking developers trying to dig their way out of the hole with more linear thinking. So the hole was just getting deeper. And so you need to do this. And it would be almost impossible to convince them that they were doing something wrong, even though everything was going very badly for them. And I thought but there has to be a better way to do this. There has to be, we need a new language, we need a new way to think about this. And as I started to discover the ideas behind residuality, I discovered that by blending Kaufman with standard software engineering ideas. And then I would show it. Some people would get it. Some people got it, started using it, said, yes, this works. This is good. Some people just refused it and said, this doesn't make any sense. And I started to dig around, why does this not make any sense to you? And I started trying to understand what way do these people think? Why do I think differently than a large number of the developers in the community? And I noticed that they were thinking in very rigid terms, and I started to read a little bit. Why do I think like this? Why do they think like this? Why do some people have a problem when I say that everything is moving, everything is changing? And that makes them nervous. And they immediately revert to using tools and ideas and modeling stuff that is trying to keep the world still. And I realized that a lot of these linear thinkers, they need to keep the world still so that they can focus and they can start to process it. And as soon as you try to keep the world still and stop the world from moving, then you enter into this matrix-like reality where you're dealing with something that isn't really there, like Baudrillard and like Bourdieu's story. And so what happens then is that you end up seeking this stillness in everything. You're trying to hold things still. And we do that in our modeling, and we do that even with certain agile techniques. We're trying to keep things still. And what what I started to do then was to say, well, what happens if we just let things move? Well, how would our software look if we weren't trying to keep it still, if we were building software for a world that's constantly in motion? Residuality was the sort of codified way to talk about that. And that's how that's how I ended up getting deeper and deeper into philosophy. Why do they do this? Why do we look for an abstract form of customer instead of building a system for something that's constantly moving and constantly changing and is never going to be the same over time? Where did that idea come from? And so I dig backwards and I find these ideas in Plato, Aristotle. Why do we expect that there's always going to be a simplistic cause and effect model in every system? And I find that, well, that came from Descartes and Newton. Why do we think there's a structure in the language that people use in a business? Why do we think that that language represents some secretive hidden structure that if we just scrape at and analyze enough, we'll find it? You find that in Saussure and Levi Strauss, and these ideas around structuralism. And so eventually I realized that we are a blend of a bunch of ideas from a bunch of philosophers no one's ever taught us about, that we accidentally absorb from our industry. And you can start with the fathers of computer science. So Turing and von Neumann, you work backwards and you realize that Turing and von Neumann both worked with Wittgenstein and Russell, who was influenced by Frege. And you take another few steps back. So it doesn't take long to get back to Plato and Parmenides. And you realize that, God, this is not something that's just turned up in the last 50 years. This is a way of looking at the world that's been around for a very, very long time. Starting with Parmenides and Plato and this need to hold things still. And that idea was triggered to that idea by reading Popper and Popper's criticism of Plato and Plato's need to hold things still, which is apparently a very controversial opinion, which upsets a lot of philosophers. So that's how I ended up digging into these things. And it has been quite a few years of reading and getting deeper and deeper into these things. Several times told by my professor to stop. It's like, you don't need to go this far. This wasn't the assignment. Leave it alone. But I got very, very into it and had a lot of fun with it as well.
What was it giving you? I mean, from my perspective, reading it, and by the way, it's wonderful how you go from logical positives and understanding how that affected Turing and how that became sort of coding and this linear mindset. And then you also even can talk about Hegel and the pragmatists and process philosophy. It's kind of amazing, actually, that you can hold all of that. But I'm wondering what that process did for you. From my perspective, it seems like it let you hold the paradox. It let you hold both things, because I don't hear you saying, okay, we're going to get rid of the linear mindset. We're not going to have that coding anymore. But I do hear you saying we're going to embrace uncertainty. And that, I think, is almost like a dissonant state to be in, that we all are trying to come to terms with right now in different ways.
Yeah, if we got rid of the linear thinking, there would be the crisis would be indescribable. We need to be able to think linearly to make code work, because code is linear. It will only follow linear rules. And if we gave that up, we'd be in real trouble. The thing is that we need to be able to do both. If you're a software architect and your task is to design software systems that have to help people do things in a complex process-oriented world, then you have to be able to make the linear thing work. You have to be able to do both at once. And you can't use one to cancel the other out. You can't use one to get rid of the other. And that's the paradox, that we have to be able to hold both of these. One of the things that's really hard for an architect when they're learning is when do I use which mind, when do I use which set of thoughts, when do I use which set of processes, what am I dealing with right now in front of me? Do I need to think linearly and be rigid here, or do I need to relax now and let this flow? And we get this wrong a lot, and it annoys people. If you real business people who do have real jobs, they get annoyed at software engineers who turn up in a meeting and start being rigid and saying, yes, but what exactly does this mean? And when we get that wrong, everyone gets annoyed at us, because we force people to a rigidity that they're not used to in their everyday working lives, and it scares people and irritates them. And it's very, very difficult for us to learn. It takes a lot of time to master this. And in our educations, in computer science, we're only taught the linear thing. So to learn the other side of the paradox, you have to pick it up. You have to pick it up in real life projects, and it's sink or swim for most architects. It's you either pick it up, in which case you're good, but you don't actually understand how you achieve your own work, or you don't pick it up and you draw and you go back to programming and say, I can't do that, it's horrible. Because there's no one to teach us. Until now, no one's really articulated these things, has said even said that this paradox exists. And so we try to survive by rules of thumb and silver bullets and products and tools that are going to conquer this complexity, get rid of complexity, and actually achieve this goal, which was never going to go away, of actually holding things still, so that we can bring them to software and control them. There's a big need for control in there as well, which you'll find is everywhere in the community.
Well, that's where that complexity and process philosophy and comes in, because you start, as you show, and as those philosophers show, you can't get outside of all these systems, which is why when you write some code, inevitably, in a year or 5 years or whatever, it's going to have changed, because we're all part of this. That's that complex system mentality that I feel like probably takes some time, but I can imagine this is going to be really, really helpful for a lot of people in coding, in software architecture, in the world too. But I want to ask you about this. Like I brought up that it was kind of the Newtonian mindset, and you're doing the complex systems or systems thinking, and it's a very different worldview. And I guess we don't have time to go into what the Kaufman network is and NKP and all of that. But is it fair to say that you've sort of unstuck the model from the object, or it's not stuck anymore? You're sort of making a model itself that can be a little more fluid. It's more based on maybe, you mentioned Bayes. That's when I was thinking of statistics, but there's some room now. There's some wiggle room, and you can notice patterns in a different way. How would you explain that to someone who's not really like getting that? Because I think it's a very big shift that you're making.
Yeah, I would say that software engineering, up until I started writing about this, had order and certainty at its center. And the goal was, no matter where you were in the project, no matter where you are in a problem, you might be dealing with some uncertain stakeholders, you might be dealing with a problem that's not properly defined, but your goal was always to get rid of that uncertainty and get to the certainty. And what I've done, what I think I've done, is I've taken uncertainty and I put it right in the middle, and said that uncertainty is the defining feature of software design. And once we embrace that, once we accept that, once we accept that we're not getting rid of it, it's always going to be there. And here's a set of tools that allows you to live comfortably with this uncertainty, and not only that, but to leverage the uncertainty to get to a result which, while it's not certain, is scientifically as good as we can get. That shifts everything, and it shifts the way we talk, it shifts the way we look at problems. The feedback I get from developers and people in the field is that it's a relief. It's like, wow, we don't have to pretend anymore. We don't have to pretend that there's this linear, logical way of solving this problem. And we can say that actually nobody knows, but here's the best way to get to an acceptable result. And that's the shift. And the other shift is that those senior architects, I've spoken to a lot of them, who have learned how to do this by instinct, suddenly have a vocabulary, suddenly have a way of saying, this is what I do, this is how I get to a result. And that is also brings a sense of relief to a lot of the community.
That's actually huge, and you just don't feel like an imposter anymore. And also, I guess what I was trying to get at too, with the philosophy, seems to have brought you back into the real world in a way that you can feel connected again. There's this sense of enthusiasm, play, life, which I think a lot of us are losing now by totally embracing the linear coding, LLM tells us everything mindset. Is that fair? Did you wake up to life in a different way again by being able to almost like put the roots into all this and understand it better?
I would say that, given my education, which was pure mathematics followed by software engineering, that the education and this default philosophy that all people who follow that track that I talk about in the book pick up, shuts you out from a huge chunk of the world, a huge chunk of life. And you have to find other ways to get back to that. Most of us have hobbies and things that do that. And what the philosophy has done for me, while staying very close to the code, is brought me and pulled me into contact with all kinds of things. And so I used to be an avid reader of literature before I got into software, and then I didn't have time for that anymore. The philosophy thing has pulled me back into that world, and maybe, sent me down a whole bunch of different trouser legs. Said, "Oh, remember this thing, and let's go back and read this." And absolutely, I would say that following this path, at this age, I would say now that I finally feel educated. I've learned something, and it's so much broader than the narrow kind of mathematical computer science, software engineering way of looking at the world. This is one of the things that I think that software engineering education needs to really think about, that we're not just producing clones who sit and write code that can be replaced by LLMs, but we're producing human beings who have to interact with human systems, and we're sending them out there with knowledge of nothing more than the code to interact with these human systems. And we're doing them a disservice. We're making their jobs harder. And to be able to build software requires that you can interface with both sides of this. And certainly for me, the study of philosophy has made that much easier to articulate and to understand. But at the same time, I can't expect the whole industry to do what I've done, which has taken an enormous amount of time to do that kind of reading and thinking about these things. And so,
Yeah, but you condense it very well into your book,
yeah,
so it's quite a service, I think.
yeah,
And it reminds me too of, I mean, you also, it's a way we can embrace entropy. There's a way in which you're opening people to be more random and let in more entropy. At the same time, you're also showing a way to, I don't know if control is the right word, but get that in order. You know, this idea of residuality actually gives you a way to kind of get that in order. I don't know if that makes sense. I thought maybe we could give one example before we go. I don't know. I'm thinking of the one with the cars and the meat or something, some kind of real world example where you can see that you've unstuck things where you're not looking at specifics, and yet because of that, so much more seemingly random stuff gets covered by the model. I don't know if you have a good example or idea to share with people.
yeah. So there is the example in the book, which is the classic example. I get sent examples of this by students all the time, and so what we do is we randomly simulate an environment sometimes with nonsense. Right? So we make stuff up and we say, what would happen in this system if the entire city burned down? Or what would, the classic one that initially got me a lot of attention was, what would happen if giant fire-breathing lizards come up out of the Baltic Sea and destroy the city? What do we do then? What does our software do? And people find this ridiculous, and this is the bit where the linear thinker says, but there are no giant fire-breathing lizards in the Baltic Sea. And then, and sometimes I tease them and say, are you sure about that? Like, have you been in a submarine down there? But the point is that the giant fire-breathing lizards don't have to exist, because what we're doing is we're discovering something in the attractor space of our business. And maybe it's not a giant fire-breathing lizard, but maybe the city is suffering a blackout. Maybe there's a terror attack or a war or a social unrest or a flood or something, and it causes ripples through our software system. And the only reason we're doing this is not to solve the problem with these lizards, but we're doing it to see, where does it ripple in our system? What does it touch? And which bits of our system fall over when that ripple comes? And by generating lots and lots of noise, by generating lots of sort of simulated stress on a system, we force a system to a configuration, to a set of modules and links between those modules. And this is the classic question: what are the boundaries for my modules? That we can't answer. And that gets answered by stressing a system until it takes on a form. And once it takes on that form, then we start to test it, and we start to see in every single case, we start to see that the system, when it's pushed to a configuration in this way, will start to survive things that it hasn't been designed for. And that's what we want to get to. And there's the example in the book of the car charging network, which is able to stand up after using lots and lots of different kinds of stress from different angles. It's able to stand up against stress that we didn't see. And one of those stresses was the politically motivated blocking of fast car chargers, and it turned out that by allowing other forms of stress to push the system to a certain point, that the system could survive those things. And these things turn up a lot when you're doing this work. It turns up very, very quickly as well, which is a shock to people who are practicing this for the first time. And there, I mean, the car charging one is the classic example. Most of the times when we discover these things, we're not really allowed to talk about it because they're genuinely live customer cases, and they don't want their vulnerabilities to be revealed.
Of course not.
But
But the idea is this hyperliminality. I think that
yeah,
this word hyperliminality is quite beautiful. But so
yeah,
there's a different approach than, I don't know, maybe you would describe it like a Deleuzian walk, or how would you, what about that hyperliminality? Now that I brought it up, I guess you're gonna
yeah.
have to.
So hyperliminality is the state where we as software architects have to live in the rigid linear world of software. We can never escape that. Our job is to design something that's rigid and linear and follows the rules and does the same thing every single time. But then we've got to jump out into this complex human world, and we've got to ask the question, is this rigid thing that I just built going to stand up in this world that keeps moving? And then you've got to jump back into the rigid thing and tweak it a little bit so that it will still keep running. And so, and that's the difficult thing. So sometimes we've got to be rigid and linear, and sometimes we've got to accept the fluidity and the flow of a business as it moves around its software. And so I've called this idea hyperliminality, because we're constantly in between. We don't really know where we are, and we're constantly moving between these 2 points. Um, and that means, so hyperliminal is a word I use to describe a certain type of system, which has an ordered, structured core and a complex bubble around it. And that's what we have to work with, which is very different than a lot of sort of complexity theory, which focuses on the complex bit, or standard engineering, which focuses on the rigid piece. But we have to do both at once, and that's where that term. I needed a way to describe that.
Yeah, it's
And
great. And I think it's good. It feels like what happens when people will just have to go watch your talk about residuality to really get the details. But you put all these stressors on, like, for example, the giant lizard, these kind of things that seem crazy and they're kind of playful and random. But then from the residues that come out of that, you end up, via these dynamical systems and this complex systems way approach that you've built, then you do end up with this thing where, for example, someone can do something like drive their giant pickup truck and block the charging station, or even someone put meat in the charging station, and actually, the way that this is designed actually will take care of that so that the company's not losing money. I'll have to let
yeah,
people just go, look at that. But
yeah,
that's kind of hyperliminal, isn't it?
yeah, it's very difficult to describe quickly, because that talk, you need to build it up for 45 minutes so that
Yeah.
everyone has all the concepts to understand what actually unfolds. But the idea is that the way that the way that traditional architecture succeeds is not the way that it's described. And so traditional architecture has a bunch of tools, like you gather requirements and you model risks, you do all of these things. And the truth is that none of them actually work. None of them actually give a result that's verifiable, or there's no way of verifying that these things are real. And what the architect learns is that each one of these things triggers a walk around the problem. And the particular tool in itself triggers you to walk around the problem from a different perspective. And as you walk around the problem, and so it's very much like Deleuze's difference in repetition. You're repeatedly contemplating the problem from a slightly different perspective. This is sort of Nietzsche's eternal return. You're constantly experiencing the system over and over and over again from slightly different perspectives as the system changes, and as you change, as you move around it as well. And what this does is it leads to a real knowledge of the system, which is much, much deeper than the shallow linear static modeling of the system, which we think we're doing. And so the outputs of these walks are static models. But what's actually happening in the mind of the architect is real knowledge is being built in a very process philosophy, sort of Deleuze-Bergson kind of way. And so what we've done is we've tricked ourselves into thinking that we're delivering these static, rigid, linear things. But what the architect's actually doing is walking around the problem. And every time they walk, they discover these attractors. And what residuality does is it says, look, here's our super fast way. We're gonna stop walking. We're gonna run now. We're gonna discover these attractors really, really quickly by being random rather than using tools and all this baggage and static modeling that comes with it. And we're going to do that in a way that produces code structures in a way that that code can cope with time and change and the uncertainty of those changes over time. And what residuality does is it takes the learned practice of architects and boils that down into something that's much easier to understand and gets rid of the baggage. And that, of course, creates a reaction from the people who are responsible for the baggage and who make money on the baggage. So that creates some ripples in the industry. But what it does is it gives us a very lightweight way to cope with these problems that just a few years ago seemed insurmountable. And it gives us a way to validate and verify. We can come up with numbers that show that this is actually working. We've actually done something here. We've built a system that is more likely to survive off spec than the system that we started off with, and it can be measured and shown that we've made progress. And that's a huge jump forward for architecture, which mostly runs on vibes. So that feels like a big step.
It feels like a way to think differently, or to be able to change your perspective as a way of thinking. I think there's a lot of people trying to figure that out, and this is very exciting that you're doing it in coding and development and so on. And as you were talking, I was thinking in the book you talk about like knowing our limitations, but you're also expanding the horizons. So I think this paradox and holding it is really quite powerful if one can sit with it and start to practice it. Have you found that? Have you found that over time it becomes a bit of a practice almost in the way you think?
It does, yes, absolutely. And I get one of the cool things is when I'm teaching students how to do this, is that they'll suddenly start analyzing completely different problems with the same set of tools. And I got this question today. I get this question every time I teach these ideas. It's like, can we use this to do this? And people will ask, have you spoken to any government agencies? These government agencies who take care of disasters and things, because this stuff could be really interesting. And there's a million, as I said, there's a million things I could chase here, a million ideas, but there's too many, And what I've said so far is that scientifically, I've been able to verify that this works for software. And it seems like it might work for a whole bunch of other stuff, but I can't be sure that it's going to work. That I don't have the time to actually verify and validate it. But people start to spin off, look at different problems from this perspective. And they ask, can we design an organization in this way? And I'm like, it feels like we could, but let's not get carried away. Let's have some validation of that. And I think there's some people in Antwerp actually doing some research on that to see if it's possible. But it definitely it shifts how you look at things. And I think for some people in software, it's been a huge revelation for them to say, oh, there's this totally different way of looking at the world, and it opens things up. It makes things freer. And for most software people, it makes it easier for us to admit what's actually happening around us instead of having to hide behind this shield of technical rationality where we have to pretend that we're logical and rigid and structured and everything's going the way we planned it and we are in control all the time. And this makes it a lot easier while still not giving up and just saying, look, whatever happens, happens, and we'll just code our way out of it when it goes wrong. We're saying there is a structured way to put uncertainty at the center and leverage that to produce better software and better architectures.
Yeah, and I think you also bring back play in a way that I think is important right now. And it would be too much to go into, but I do feel like we're getting kind of routed into thinking that the technology we've built is the way to think, which is very strange. It's very, very much a kind of closed loop that ends up, I think, in stillness. So it's wonderful that you put some uncertainty in there and inject this real life back into this world. I really appreciate that holding the being and the becoming, the criticality instead of just the correctness. I mean, these things, however one gets into it, it really is a way of thinking that brings you back to life, and I think we really need it right now.
Yeah, and that's one of the coolest things to see is when I'm teaching people and they start doing this for the first time. And they're used to, discovery in a problem domain. When you're working with tech, has been so, it's drudgery, everyone hates it. You've got to torture business people and ask them explicitly, what do you mean by this? And you write it up in a contract so you can say gotcha later on, that's not what you said. And suddenly there's this sense of play to it. And we're talking about lizards and we're talking about stupid things. And someone then gets a bit silly and says, but what would happen if aliens came and they destroyed the city? And then we say, well, what would happen if aliens came and they became our customers? How would that change things? And that gets to be a lot of fun. And then people realize that, there's even though we've been messing around for the last hour, we're starting to see where the ripples hit this system, and we're starting to see real design changes that have to be made out of this. And we're going to be able to validate and verify in a few hours from now that this architecture is actually more reliable, more solid than it was before. And that's shocking, and people love the playfulness of it. And it's great to see that, because there's a lot of nerves around these things. It's people are tense when they're working with requirements and risks and trying to get these linear tools to work in a world that just isn't built, just isn't going to suffer them. And to be set free from that, I think is fantastic.
Me too. And before we go, I have to bring up the word love because it's love and philosophy. But
Yeah.
And I know it's kind of an uncomfortable word, but I do feel like this is kind of, I don't know from your position if it feels like an act of love, or if if that connects at all. But it does feel deeper than just what it could be, which is you've created this great new cool thing for the world. But how does that word strike you? Is it involved in this at all?
I think a little bit. I think that one of the things I'm encouraging architects to do when I'm teaching these ideas, and I spend a good bit of time talking to them about this, is to look inward and to say, like, when you've made these decisions before in your career, why did you make those decisions? And this makes everyone tense, right? Because they don't know. And I say, look, the first thing you've got to do is forgive yourself, because it's totally okay to not know why you made these decisions. Everyone's in the same boat. Look around, look in the room. Everyone is thinking the same thing. I've learned how to make decisions, but I don't exactly know how I'm getting there. And appreciate the ability that you've built up. And now we're going to, look inward and understand, why do I make decisions? How do I make decisions? Can I understand, using these tools, using these philosophers, using these ideas, can I understand how I arrived at these things? Can I understand how I work and think and look at the world internally? And we spend a lot of time talking about the kind of things that architects, software architects, sit around and moan about. And we sit around and moan about the fact that our stakeholders are mean. They don't invite us to the right meetings. They lie to us all the time. They don't know what's going on. They might be kind of stupid. They're not as good as us at this linear thing, and they don't express themselves properly. They don't understand logic. And there's a lot of bitterness that builds up in these things. And organizations are designed to make sure that architects can't do their job properly. And there's a lot of bitterness and frustration that builds up. And so by looking inside and by understanding why these things happen, it's much easier to forgive the people around you, the stakeholders around you, for their behavior, because it's not intentional. All of these things are brought about by the very same uncertainty that we're now leveraging to do something good with. And what I'm actually doing is encouraging people to forgive the people around them, and to stop seeking conflict, which is something that software people really need to get better at, and to get rid of all this bitterness and frustration that can build up. And then you're much more open, you're much easier to do these things, and there's going to be a lot less stress in your life. And that's one of the things that software people need to get rid of in large organizations, so that we can approach these things. And I guess that has its relation to the concept of love, and they're getting rid of a lot of the negative emotion that makes it impossible to build relationships with people and makes people not like us software people. So absolutely, I think that this opens things up.
Which is a big part of the world right now. We met, I think, because of this That's Not Philosophy, this thing where I was
yes,
where people, there's, I guess the point is, there's a lot of people, a lot of young people who are doing this now, who are in this world. I mean, it's a huge world, and it's wonderful to be able to hold these things in the same way that we've been talking about all this other stuff, that you can look inside, you can, I think people are hungry for this. And we tend to pretend like it's too sentimental or it doesn't matter, but as you just explained, it's part of it. And it doesn't mean you give away all the linear stuff and all the, kind of hard edge stuff,
Yeah.
criticality. But, you can also have that in there. And it's really uplifting for me to see someone like you who has so much success and who is, could be just one of those people who block it all out, actually looking at it in a way that's balanced and real.
Yeah, cool. Good to hear.
Is there
Thanks.
anything that we didn't talk about that you want to say, or anything you want to be sure everyone knows, or any websites? Or, I mean, of course, I'm going to link to all your stuff, but if there's anything.
No, I don't. I think you probably have the books are the easiest way into this. I think most people come into this through the YouTube videos of the conference talks that are out there. I don't think there's anything to try it and see. If it works for you, then great. There's a whole new world of how to think about your software and how you think about your decisions in there for you. And the book, the book, The Architect's Paradox, has two. It has two personalities. One personality is to shine a light on this paradox that we all suffer from, but the other thing you'll get out of that is, as an architect, it's an introduction to philosophy in a way that's going to be relatable, because we're talking about software and we're not talking about Plato, blah blah blah. We're saying Plato had this effect on software, and you'll see yourself in it, and you'll remember these things way more than if you read Russell's History of Western Philosophy or something, which I think most developers have got to like page 30 and it's on a shelf in their house. Or sorry, most software engineers have got to page 30 and it's in a shelf in their house somewhere. This is accessible. And it opens up a whole world that we're excluded from because of our educations, and we don't have time because of our careers, and it's absolutely fantastic. And there's just so much to be gained, not just in your software, but in your life in general, from reading this stuff and understanding the world around you. And like you said a few times, it's a way back. It's a way back from the code, because at some point in your career, you're going to look up from the screen and you're going to realize there's a bit more going on than what we've been focused on. So
yeah, I think we all feel that too. Anyone who's ever coded, you can get so lost, and it gets hard to touch reality again. So it's good to have some paths back. I hope you're also taking care of yourself. It must be overwhelming for you right now too, with all this.
Yeah, there's a lot happening, and to be fair, I've brought it all on myself, and but it's exciting at the same time. And my saving grace is that I live in Sweden and we don't take work that seriously. And I'm about to take several months off for the summer and go north and fish with my family. So, we have that. But it's good. There's a buzz happening right now. It's exciting.
Yeah. Well, that's good. Well, thanks also to your wife, by the way, for giving you those books, because you talk about her a few times as kind of the portal into all this. So that's cool too. Just that's connected to love too.
Yeah, it's almost her fault.
All right, Barry. Well, thank you for all you're doing, and good luck. And I look forward to the next book, which I know is coming soon.
Yep. Great. Thank you.
All right. Be well.
Cheers.
Bye.